Voyager 1 is the furthest man-made object from Earth ever created. It is currently 24 billion kilometers away from us, and it's not slowing down. Right now, it is speeding into deep space 14 times faster than a bullet, but last November, Voyager 1 went silent. But just a few weeks ago, NASA revived Voyager 1, and all systems are now back online. Voyager 1 lives to see another day. This did have me thinking, how much further can Voyager 1 travel before it runs out of power, or we lose contact with it? If this famous image of Earth was taken by Voyager 1 back in 1990, what if we turned on the cameras now? What would we see? And maybe most importantly, what happens thousands of years from now if humanity is no longer around and something, or someone, finds Voyager? So let's go on a journey together. Where is Voyager now? Voyager 1 was launched on September 5, 1977, sent on a journey for the outer solar system to investigate the beautiful gas giant planets before leaving our solar system on an endless and lonely journey into the cosmos. I've told you that Voyager 1 is the furthest man-made anything from Earth, but it's kind of hard to truly grasp just how far away it really is. This is our Earth and Sunday. The distance between them is known as an astronomical unit, and equal to around 150 million kilometers. Voyager 1 launched from Earth on September 5, 1977, on a journey to leave our solar system for good. Traveling at 61,000 kilometers per hour, it took 1 year and 6 months for Voyager to travel $5.20, passing Jupiter, taking these jaw-dropping images in the process. 3 years and 2 months after launch, and Voyager had made it to Saturn. That's when its long and lonely journey really began. It would take a further 31 years of travel at this immense speed to finally pass the heliopause boundary. This is the point where the Sun's solar wind is no longer strong enough to resist the interstellar medium. It's essentially the boundary of the Sun's influence. And while you might think this is the boundary of the solar system, you'd be wrong. Let's zoom all the way forward to today. In 2024, Voyager 1 is around 24 billion kilometers away from Earth, or around 163 Australian dollars. That is more than 4 times the distance from the Sun to Pluto. At this distance, it takes our radio signals 22 hours and 36 minutes to make it to Voyager, and a further 22 hours and 36 minutes to receive any messages back. While I know this seems so far away, in the grand scheme of things, Voyager 1 has barely left home. It will take a further 300 years before Voyager 1 reaches the Oort cloud, a sphere of icy rocks surrounding our solar system, and it will take a further 30,000 years to completely pass through it. Now think about where Voyager 1 might be in a million years from now, a billion years from now, and who might find it. How do we contact Voyager? So I guess the question is, how do we even stay in contact with Voyager 1 if it's just so far away? Really think about that. NASA engineers saved a spacecraft launched nearly 50 years ago remotely from Earth. That's pretty special. NASA communicates with Voyager 1 using their Deep Space Network, a system of huge telescope antennas located all around the world, in California, Australia, and Spain. These locations were specifically chosen so communication can be maintained throughout the entire day as Earth rotates around. Radio signals are sent from Earth and then take around 20 hours to reach Voyager. Once the message is received, Voyager's onboard computers can process the instructions before sending a response back to Earth. This response signal again takes around 20 hours to reach us, where it's then received by massive 70-meter wide radio dishes and an array of these 34-meter dishes. To give you a scale of just how weak the signal sent from Voyager is, the radio signal is sent back by a transmitter with a power level of 20 watts. That's about as strong as the light bulb in your refrigerator. Despite how weak the signal is, these huge dishes on Earth are able to capture these whispers from the cosmos, allowing for data about what Voyager 1 is experiencing out there to be received here on Earth for hours every single day. But signs of Voyager's age are showing. In November last year, Voyager started sending back random strings of data that made just no sense. Of course, conspiracy theorists jumped on this, claiming that aliens had captured Voyager 1 and were using it to send messages back to us here on Earth. This is of course not what happened. Engineers located the issue with the flight data subsystem, created a workaround, sent the code to Voyager and waited to see if it worked. And Voyager 1 survived. Communicating with Voyager doesn't seem to be the problem. So why then is everyone saying lately that Voyager is dying? The real answer is, Voyager's running out of power. Voyager 1 is powered by 3 radioisotope thermoelectric generators, or RTGs. These are nuclear reactors converting heat from plutonium decay into electricity. But this of course means that over time, the fuel source gets used up. To conserve power, NASA engineers have been turning off the non-essential systems and instruments. Things like heaters and redundant scientific instruments, including the camera. NASA have said that sometime over the next few years, the power levels will just be too low to support the critical systems. And at this point, Voyager 1 will go dark forever, drifting through the cosmos alone for eternity. Now before we continue with the story of Voyager, I'd just like to thank Odoo for sponsoring this portion of the video. As you all should know by now, Odoo is an all-in-one management software that provides entrepreneurs with a whole range of applications to simplify managing a business. Their website builder application allows you to create your very own beautiful site quickly, easily, and best of all, free of charge. Your first Odoo application, whether it's a website or one of their other offerings, is completely 100% free for life with unlimited hosting and support. So to be honest, there is really just no reason to not give it a go. You can create your very own site in just 4 easy steps by defining your business goals, choosing a color palette, or dropping in your logo, adding the pages and features that you want, and then finally, choosing your theme. You'll even get a free customer domain for an entire year if you sign up now. Then once you add more applications, you can switch to one of their affordable paid plans. So to check out Odoo, just click the link at the top of the description, and in doing so, you'll be supporting the channel. What if we turned Voyager's camera on? On Valentine's Day 1990, Voyager 1 was 6.4 billion kilometers away, leaving our solar system for good. But down here on Earth, a man had been campaigning, saying we should turn Voyager 1 around one last time to take a picture of Earth. Everyone said it would be a waste of energy and there was no scientific value in taking that picture, but he insisted. And thankfully, NASA agreed. This man was of course Carl Sagan, and the image we received, the pale blue dot, may be the most iconic image of Earth ever taken. In this picture, Earth is just 10% of a single pixel in size, captured as a tiny speck in a scattered light ray. And yet that's all we know. That's where you are right now. This has me wondering, since Voyager 1 is about to go dark forever, what if we turned it around one last time and turned the camera back on to take one big family portrait? What would it see? So I did some simulations and this is what I came up with. The sun visible as a faint and blurry dot of light surrounded by planets you can barely make out. So while the pale blue dot showed us our home, this is our cosmic neighborhood, our planetary neighbors lit by the sun. And because the universe is just too big, this is probably all humanity will ever know. For the rest of time, this is our home. As Voyager 1 shuts down operations in the coming years, it's hard to not imagine what the future holds for this amazing spacecraft. Once the onboard power is depleted, the instruments will no longer work and no more data will be sent home from Voyager. The end of an era. But for Voyager, this is still just the beginning of its journey. It will continue through the Oort cloud for thousands of years, finally leaving the outermost extent of our solar system for good. It's out here where Voyager will orbit our Milky Way every 225 million years, just like us, passing by neighboring stars every now and then, a beacon of our humanity. And if someone is out there looking and stumbles across Voyager, they will have all the clues they need to find us. The golden record contains everything they need to learn about our little blue dot, what animals we have, what our languages sound like, many images and audio recordings, and most importantly, where they can find us. So when that day does come, when Voyager goes quiet for good, we can all agree that Voyager 1 completed its mission and much, much more, giving all of humanity a beacon of hope.
Absolutely, there is life elsewhere and almost certainly intelligent life. It has to be. The odds are just overwhelming. A recent revelation has sparked intrigue and wonder among scientists and space enthusiasts alike. Renowned science communicator Bill Nye caused a stir when he revealed that Voyager 1 had detected 300 massive objects in space. This revelation has not only piqued our collective imagination, but also sparked profound questions. So what are these objects, and where do they come from? Come along as we unravel the mysteries hinted at by Voyager 1's astonishing revelation. For nearly 50 years, the Voyager missions have given us some of the earliest and most remarkable views of our solar system's wonders. Surprisingly, these missions were not built to last so long. In the 1970s, Michael Minovich had a breakthrough idea. A spacecraft could use a planet's velocity to propel itself further into the solar system. Initially planned to last only 5 years, the Voyager mission has far surpassed these expectations. Voyager 1 and Voyager 2, launched just weeks apart in the summer of 1977, were first set to explore Jupiter and Saturn. They achieved this mission by successfully studying these gas giants, but they didn't stop there. Voyager 2 went on to make the first ever close-up observations of Uranus in 1986 and Neptune in 1989. These flybys of 4 planets earned the mission the name Voyager Grand Tour. Instead of ending their mission, the resilient Voyager spacecraft set their sights on an even more ambitious goal, exploring deep space. Now, 46 years later, Voyager 1 and Voyager 2 are still traveling, gathering essential scientific data from the far reaches of the cosmos. In a groundbreaking announcement in 2013, NASA revealed that Voyager 1 had officially entered interstellar space. Interstellar space is the region between stars, beyond the influence of the sun's particles and magnetic fields. It's like moving from a busy solar system into a peaceful, star-filled wilderness. The Voyager story continued in 2018 when Voyager 2 also entered this vast region, 17.7 billion kilometers away from the sun. Remarkably, Voyagers 1 and 2 are the only spacecraft to have ventured into interstellar space. These pioneering spacecraft have been studying how the interstellar medium interacts with the solar wind from our sun. NASA's Voyager 1 and 2 spacecraft have been our primary source of information regarding the heliosphere, a protective shield enveloping our solar system. The heliosphere is shaped and adjusted by the solar wind, a continuous stream of charged particles emitted by the sun. Voyager 1 and 2 have acted as our cosmic reporters, sending back valuable insights about this celestial shield. Where does all this information converge? At the heliopause, the official boundary of our solar system, marking the transition from the solar wind to the vast expanse of interstellar space. NASA's Voyager spacecraft has provided valuable new knowledge about interstellar space. One significant finding is that cosmic rays, mysterious particles, are 3 times more intense beyond the heliopause compared to within the protected area of the heliosphere. This difference is like comparing the tranquility of a backyard to the bustling activity of a busy street. However, there's more to this cosmic drama. NASA's experts didn't stop with Voyager discoveries. They integrated data from subsequent missions with Voyager's observations, creating a comprehensive portrayal of our sun and its complex interaction with the surrounding interstellar space. In a grand cosmic performance, NASA scientists made a surprising revelation last year. Voyager 1 captured a low humming sound that matched the vibrations detected in small amounts of gas floating in the vast emptiness of interstellar space. Nicola Fox, the leader of NASA's Heliophysics Division in Washington, D.C., stressed the importance of the Voyager missions. In her words, over the past 46 years, the Voyager missions have been crucial in providing us with this knowledge and have changed our understanding of the sun and its effects in ways that no other spacecraft can. Now, that's quite an adventure in space. Voyagers 1 and 2 rely on a power system fueled by plutonium. However, as the plutonium ages, it produces less heat, causing the Voyagers to lose power. Facing this cosmic challenge, NASA had to make tough choices, shutting down non-essential systems and even some initially deemed necessary. The heaters meant to keep instruments warm in the freezing expanse of space were turned off. But here's the surprise. Despite the odds, All 5 instruments have been functioning well since 2019, defying expectations. NASA experts are puzzled, wondering how the Voyagers are still operating in temperatures that would normally freeze other spacecraft. It's a mystery that deepens the remarkable legacy of these brave space pioneers, adding another layer of wonder to their enduring journey. The outer edges of our solar system are surprising astronomers with unexpected behavior. The heliopause, which acts as a boundary between our sun's influence and the space between stars, is not staying still. Instead, it's moving and creating strange angles, leaving scientists amazed and puzzled. This idea of the heliopause changing shape isn't entirely new. For the past 10 years, smart researchers using data from Voyager 1, Voyager 2, and NASA's Interstellar Boundary Explorer satellite have noticed the heliopause tendency to change. These spacecraft are incredibly important as they give us direct measurements of these cosmic borders, even though it's just at one specific spot in space and time. Dr. Eric J. Zirin, a space physicist at Princeton University, shared some exciting insights in an email to Vice. He mentioned how IBEX, another satellite, is adding valuable data to help scientists make better predictions about the heliopause future movements. Now, here's where it gets more interesting. Recent studies have challenged what we thought we knew. IBEX noticed a strange brightening of energetic particles in 2014, suggesting some irregularities in the heliopause. However, these irregularities didn't match our existing models, almost like a surprise twist in a story. Moreover, researchers saw significant changes in the heliopause position in a short time after studying data from Voyager 1 and Voyager 2. This movement might explain why these two probes reached interstellar space in 2012 and 2018, respectively, with a big gap in between. These unexpected behaviors are not just confusing. They contradict what we thought we understood about the heliopause. In a recent article in Nature Astronomy, scientists referred to these discrepancies as intriguing, meaning they are puzzling and could cause some debate in the scientific community. But don't worry, the search for answers continues. Scientists are eager to learn more from NASA's upcoming Interstellar Mapping and Acceleration probe, scheduled to launch in 2025. This advanced satellite promises to reveal more secrets about the outer reaches of our solar system. Until then, we can only wonder about the mysteries waiting for us beyond the heliopause. In May 2023, Voyager 1 experienced an unusual event during its regular operations. The part of the spacecraft responsible for controlling its high-gain antenna, known as the Attitude Articulation and Control System, ACS, started sending back confusing data. Instead of the usual updates on the spacecraft's health and status, it seemed like Voyager 1 was having trouble communicating effectively, similar to how someone might struggle to speak fluently due to a condition like electronic aphasia. From our perspective on Earth, it appeared that Voyager 1 was experiencing electronic confusion. The data it sent back seemed random or lacked coherence, as NASA explained at the time. Interestingly, despite these strange reports, Voyager 1 appeared to be functioning perfectly fine. Its radio signal remained strong and stable, indicating that the antenna was still pointing toward Earth, contrary to what the ACS was indicating. Adding to the intrigue, Voyager 1's scientific instruments continued their operations without any issues, unaware of the anomaly in the ACS. Furthermore, the spacecraft's fault protection system, designed to respond to glitches by putting the spacecraft in a safe mode, was not triggered by this event. Fortunately, NASA quickly identified the problem. It turned out that the ACS was using a computer that had been inactive for a long time. The solution was simple, a command to switch to the working computer for data transmission. However, the mystery remained about what caused the ACS to act strangely in the first place. NASA suspected that an incorrect command from another onboard computer might have triggered it. While this incident didn't pose a significant risk to Voyager 1's safety, NASA is actively investigating to prevent similar occurrences in the future. Voyager 1 has been exploring interstellar space for over a decade, outside the protective magnetic field of the Sun. This magnetic shield, similar to Earth's magnetic field, shields the spacecraft from cosmic rays and other space radiation, acting like a cosmic suit of armor. When it comes to technology, just as Earth's computers can face challenges from high-energy particles and solar radiation, Voyager 1's onboard computers also encounter cosmic hurdles. Sometimes, energetic particles can interact with computer chips, leading to small memory errors that build up over time. Susan Dodd, the project manager overseeing both Voyager 1 and 2, provides a cosmic perspective on these challenges. She mentions that encountering such mysteries is part of the norm at this stage of the Voyager mission. These spacecraft have been on an incredible journey for nearly 5 decades, far exceeding their expected mission duration. It's worth noting that they are navigating through interstellar space, an environment filled with high levels of radiation, a territory no spacecraft has ever explored before. Nearly 50 years have passed since Voyager 1 and Voyager 2 set off on their remarkable journey. They've traveled across vast distances, delving into unknown realms and uncovering groundbreaking knowledge. These iconic spacecraft, now venturing into interstellar space, face a unique challenge. Their computer systems from the 1970s era operate with just 70 kilobytes of memory. Yes, that's right, a mere 70 kilobytes. Despite these technological limitations, NASA has successfully maintained the functionality of these distant explorers. Just imagine the effort of sending software updates across immense cosmic distances to ensure their ongoing operation. It's akin to providing cosmic IT support. Consequently, amidst the vast darkness of space, billions of miles away from Earth, the Voyager probes have crossed significant thresholds, offering humanity profound insights into the mysteries of our solar system. Let's pause for a moment to honor these trailblazing space pioneers, the twin Voyager probes. They are currently bidding farewell to our solar system, drifting endlessly amidst the stars. Each probe is comparable in size and weight to a small car. They are akin to vintage legends of space exploration, embodying the technological essence of the 1970s. True, their computer systems may be less powerful than today's digital watches, and their analog TV cameras may seem primitive compared to modern ones, but they have left an indelible mark on every celestial body they encounter. The Voyager spacecraft have taught us fascinating details about Jupiter. It's not just a calm giant. It's a planet of extremes with hundreds of fierce hurricanes, a glowing aurora at its north pole, and 3 delicate rings that are more intricate than a fancy braid. Similarly, Saturn surprised us. Its rings, once thought to be few and simple, turned out to have thousands of ringlets and braided structures that were thought impossible by experts. What's more surprising is the discovery of active volcanoes, which were previously believed to be unique to Earth. These volcanoes were found on Jupiter's moon Io and amazingly on Neptune's moon Triton. On Triton, nitrogen geysers erupted at temperatures as low as 40 degrees above absolute zero on the Kelvin scale, adding to the astonishment. But the most captivating find was the identification of potential hotspots for alien life. 2 of Jupiter's moons, Europa and Saturn's Enceladus, appear to have vast salty oceans beneath their icy surfaces. These oceans could potentially harbor living organisms, making these moons prime targets for further exploration. The Voyager mission bid a heartfelt farewell with a touching tribute to where it all began. In the early 1990s, the spacecraft captured a snapshot of our solar system, including Earth, thanks to an idea proposed by Carl Sagan, a key figure in the Voyager imaging team and the genius behind the golden record. Back in 1981, this iconic image of Earth became known as the pale blue dot, as coined by Sagan himself in his book of the same name. Sagan was inspired by the breathtaking Earthrise pictures from the Apollo program, especially the one taken by Apollo 17 from the moon's surface. His goal was to offer a new perspective, showing Earth from a distance 100,000 times farther away, believing that such an image could help us understand our place and situation in the grand scheme of things. While ancient philosophers viewed Earth as a tiny speck in the vast universe, this perspective had never been visually experienced until that moment. Fast forward to August 25, 2012, when Voyager 1 made history by crossing into the interstellar medium at a mind-boggling distance of 11 billion miles from the Sun. Remarkably, it continues to send valuable data back to us. Its counterpart, Voyager 2, joined the interstellar journey in 2018. These pioneering spacecraft are now so distant that it takes about 22.5 hours for a radio signal traveling at the speed of light to reach Voyager 1 from Earth, while Voyager 2 requires nearly 19 hours. Each day, these brave probes move another 3 to 4 light seconds away from us. NASA's Deep Space Network, consisting of 3 tracking complexes located strategically around the world, serves as their lifeline, ensuring continuous communication even as Earth rotates. As our spacecraft venture further into space and time, their signals become faint whispers. The Earth's bustling noise from radios, TVs, cell phones, and other sources makes it quite difficult to pick up these faint signals. Despite their faintness, these whispers align with astronomers' expectations as the Voyagers move into the interstellar part of their mission. This mission, a massive scientific endeavor spanning around 10,000 work years, is widely regarded as one of our species' most significant explorations. Interestingly, it almost didn't happen. The Voyager mission was a stroke of luck in celestial mechanics. Initially, Michael Minovich discovered that a spacecraft could gain speed from a planet to move away from the Sun. Building on this, Gary Flandreau demonstrated that probes launched during the late 70s and 80s could utilize a special alignment of outer planets utilizing gravitational assists.